In 1928, the Soviet Union dispatched a military commission with the aim of finding an adequate and advanced foreign tank design. While visiting the USA, they came across the automotive designer J. Walter Christie, who presented them with his own tank design. The Soviets were impressed, leading to the acquisition of 2 vehicles, followed up by a license for production of that design in the Soviet Union. The vehicle which was built in the Soviet Union was known as the BT-2, and while not perfect, would be built in large numbers and serve as the basis for future, more successful developments. The BT tanks have often been associated with the theory of deep operations. While BT tanks eventually found their place and role within the cutting-edge doctrine, the reasons why BT tanks were adopted into service with the RKKA, short for Raboche Krestianskia Krasnaya Armia, or the Red Army of Workers and Peasants, are much more complicated. In the mid-20s, the Soviet leadership found themselves in isolation, aggravated by deteriorating international relations. At the time, Great Britain was considered the primary army of the young socialist republic. Troubled with rising tensions with the international community, the Soviet leadership decided to inspect the Red Army and determine its readiness for a future war. On December 26, 1926, the General Staff of the Red Army prepared the report, quote, "The Defense of the USSR." The results were disastrous. Presenting the report to the Soviet leaders, the Chief of Staff of the Red Army, Mikhail Tukhachevskii, admitted the unpleasant fact, quote, "Neither the Red Army nor the country are ready for war." The consequences were twofold. Firstly, the situation forced the Soviet leadership to pay attention to the defense issues and urgently start a massive reorganization of the Red Army. Secondly, the Soviets and Stalin himself, who by that time had increased his influence significantly, got an opportunity to use the war scare as a part of internal policy, justifying the most extreme measures. In December 1927, Tukhachevskii sent a memorandum to Voroshilov entitled On the Radical Rearmament of the Red Army. The document stressed the fundamental technical rearmament of the army as a key aspect of a successful defense policy. Basically, the best defense is a good offense. Later, that notion became more precisely formulated, quote, "to keep up with our enemies in the strength of the mobilized army and surpass them in materiel." Accordingly, the cornerstone of the technical rearmament of the ground forces was the plan to increase the level of mechanization dramatically. Eventually, technical rearmament and mechanization of the Red Army even got its own name and became known as tankization, or tankizatsiya in Russian. The first 3-year plan, presented in 1927, only anticipated producing about 150 tanks in that time period. The next plan, part of the first 5-year plan, anticipated the growth of the tank fleet 15 times compared to 1928 and 29. This was quite an ambitious rate considering the state of the economy and industrial development of the USSR at the time. The plans for future production were mostly based on projections which clearly overestimated the industrial capacity and technological potential of the country. In reality, the Soviet tank program bumped into numerous difficulties with both development and production. The Red Army had only adopted into service its first indigenously developed tank, the T-18, or MS-1, in July 1927, and started its low-rate serial production in mid-1928 with only 30 tanks being built. Through 1928 and 29, production was moving slowly, experiencing constant delays of delivery and poor quality of production. For example, on September 24, 1929, the Ordnance Arsenal Trust reported that the Bolshevik factory, number 174, would delay production for 1 to 2 months, and the Motovilexhinsky Zavod factory, number 172, would be delayed 8 to 10 months. Additionally, in 1929, a new System of Tank Tractor Auto-Armored Weapons of the Red Army was adopted. The document made the T-18 obsolete and envisaged the adoption of even more sophisticated armored vehicles in increasing numbers. Knowing these circumstances, the command of the Red Army and Tukhachevskii himself had every reason to question the ability of the Soviet industry to cope with the plan on its own and within acceptable timeframes. In November 1929, the Upravlenie po mechanizacji I motoryzacji, or Department of Mechanization and Motorization of the UMM of the Red Army, had to admit that, quote, "there is no certainty that the program will be completed." The remedy to this situation was quite obvious: seek technological help abroad. The decision was made, and on the 30th of September 1929, the commission led by the head of the Directorate of Mechanization and Motorization of the Red Army, the UMM-RKKA, Innocenty Chayebski, went abroad. The plan envisaged visiting the US, Great Britain, Czechoslovakia, France, and Germany in order to purchase technologies and armaments. It was a juxtaposition that the Soviets were determined to find help in hostile bourgeois countries, as they were presented in official propaganda, including Great Britain, the most likely enemy state in a case of war. There was another significant point regarding the connection between the deep battle, deep operations doctrine and BT tanks. Despite the fact some elements of the future doctrine were developed by Tukhachevskii back in 1926, he was not an active supporter of mechanization until 1928 and 29, and saw cavalry as the main maneuver element of the army. In May 1927, presenting the new plan of military development, Tukhachevskii did not even mention armored forces or tanks at all. Although Soviet advocates of mechanization were well aware of the technological and tactical developments in other countries, including Britain with their experimental mechanized force and convertible tanks, there were no fast tanks in the system of tank tractor auto-armored weapons of the Red Army of 1929. The system, however, included convertible tankettes with a maximum speed of 60 km per hour on wheels and 40 km per hour on tracks, but their tactical role was confined to reconnaissance, surprise assault, or anti-tank defense in a variant armed with a 37mm gun. Obviously, not even close to the role of fast tank, which was a crucial part of the independently acting mechanized formations and the deep battle doctrine in general. Eventually, having appreciated the advantages and high potential of the new combat vehicles acquired from the US, the Soviet military command began to see Christie tanks as a unified platform, capable of performing different tasks. Quote, "This type could be used not only as a tank, but as a troop, machine gun, artillery, and ammunition transporter, etc. Also as an armored car for the motorization of the cavalry. It could be used as a platform for carrying anti-aircraft guns, machine guns, and searchlights. Field artillery could also be put on the Christie's chassis, which surely addresses the problem of the motorization of artillery. Chemical forces, signal, and technical troops could also use the Christie's vehicle," said the note on the Organization of Armored Forces Abroad issued in January 20th, 1930. We can assume that combat vehicles with characteristics similar to Christie's tanks were not considered in the early stages of working on the novel theory of deep operations. The adoption of the BT-2 tanks luckily coincided with the development on the theory in the early 1930s, and the capabilities of the military equipment successfully corresponded with the needs of the innovative theory of deep battle. During the Great War, Christie was involved in designing tracked, self-propelled artillery vehicles. When the U.S. Army obtained a number of French FT-17 tanks, Christie noted that the tank, and especially its suspension, were prone to malfunctions and breakdowns during long-distance marches. The solution used at the time were to use trucks as transport vehicles to avoid unnecessary wear of tank engines and running gear. While quite effective, this also had some drawbacks, such as the necessity to have a large fleet of trucks, which were also prone to breakdowns, hard limits on weight and dimensions, and a relatively low speed of movement. During this time, Christie came up with a new concept for a convertible armored vehicle. He simply devised a plan of using a track suspension system that could, if needed, be easily modified and used as a normal wheeled vehicle by simply removing the tracks. The first tank prototype to use this kind of suspension was presented to the U.S. Army in early 1921, named M1919. While the vehicle was trialed at the Aberdeen Proving Ground, a number of problems were noted. For this reason, Christie spent some time modifying and improving his design, which he again presented to the Army in 1923. Once again, this tank was rejected due to the many flaws in the design. Once more, Christie completely redesigned his suspension system. This time, he incorporated 4 larger road wheels, with the idle in the front and the drive sprocket in the rear. The last road wheel was connected with a chain belt to the drive sprocket, and was used to provide drive power when the track links were removed. The front road wheels were used for steering. During 1928, hence the name M1928, Christie himself made great efforts to advertise his vehicle, especially to the U.S. Army, but also to customers abroad. He actually managed to gain attention from Poland and from the Soviet Army representatives. At that time, the military and political relations between the U.S. and the Soviet Union were almost non-existent. The U.S. didn't even recognize the USSR as a state. Thus, any possible cooperation with Christie would be difficult to achieve. At the time, the main base of operations for the Soviets in the U.S. was the Amtorg Trading Corporation entrenched in New York. Amtorg was founded in 1924 with the official goal of facilitating trade operations between the Soviet Union and the United States to help with import-export operations as an intermediary. Additionally, the Soviets also used Amtorg as a cover for intelligence operations. Amtorg was actually an officially registered stock company embedded into the American market and legal system, meaning the Soviets could obtain valuable intelligence without any covert operations. Amtorg could officially request information about any company registered in the USA on the grounds that they wanted to make a deal with them. Moreover, it was impossible to prevent them from doing so, since by submitting official requests, they did not go beyond the legal field, being an incorporated subject of economic activity. In this regard, federal officials called Amtorg a, quote, bridgehead of Soviet espionage, and the oldest Soviet intelligence agency in the United States. Through Amtorg, the Soviets managed to acquire a number of technologies and later even weapons from the USA. With Amtorg, the Soviets had stationed a group of undercover military officers whose task it was to try to obtain more military equipment under the guise of purchasing that equipment for civilian purposes. While American authorities from the early 20s were strictly opposed to selling any kind of weapons or military equipment abroad, and especially to the Soviet Union, by the end of the decade, this attitude changed. To this end, at the end of 1929, Amtorg officials asked for permission to buy 50 Cunningham T-1E2 light tanks. This tank actually never entered production. But nothing came from this, mostly as the Christie design looked more promising and was more available. In 1930, a Soviet delegation led by Innokenty Tukhachevskii, who was in charge of the Red Army Mechanization and Motorization Directorate, and D.F. Budniak, the defense industry representative, visited a number of American weapons and arms manufacturers, including Christie's own plant. The Soviets were highly impressed with the M1928, and after they informed the People's Commissar for Defense, Klement Voroshilov, it was agreed to acquire 2 vehicles for testing and even obtain a production license. In June 1930, after long and difficult negotiations, Christie signed a contract with the U.S. Army to deliver 1 tank for $55,000, along with $7,000 allocated for trials and fine-tuning of the engine. In the meantime, he was approached by Amtorg representatives with their own proposal and also managed to sign a separate contract with Poland to deliver 1 M1940 tank for $30,000, along with spare parts worth about $3,000 and the production license for another $90,000. Knowing the Soviets' fears and unwillingness to allow Poland to get any advantage over the USSR in tank production, Walter Christie skillfully used the situation in his favor. By the end of April 1930, an agreement was signed between Christie and Amtorg for purchasing 2 vehicles for a total of $60,000, or about $933,000 in today's money, spare parts worth $4,000, followed by an agreement for a licensed production and technical support for another $100,000. The total sum was high enough to cover the costs resulting from breaking the previous contract with Poland. At the same time, to better familiarize with the construction and design of the M1928, about 60 Soviet engineers spent nearly a year at Christie's company. Although the contract had already been concluded, the actual delivery of these vehicles were slowed to a halt by the U.S. government. At the time, U.S. government officials were unanimous that no weapons of any kind should be allowed to be exported to the Soviet Union. At the end of 1930, American authorities tried to find out what happened to those 2 M1928s, and they were probably shocked and agitated to discover that these had already been dispatched to the Soviet Union disguised as tractors. The Christie tanks finally reached the Soviet Union in early 1931. These 2 were of the M1940 model, based on the M1931, which meant it had a more simplified frontal hull. In order to ship them to the Soviet Union, they were disguised as tractors by removing the turrets, which had to be left behind. Because of this, the Soviets had to design and build their own turrets. One of the 2 vehicles was moved to the Nahabino Proving Ground for operational trials. The second vehicle was moved to the Ordnance Arsenal Trust, or the GKB-OAT, in Moscow. The testing of the M1940s were completed by May 1931, and production orders were placed shortly thereafter. During the testing phase, the M1940 showed itself to be an unrefined design, but was put into production anyway. One of the reasons for this was false and incomplete information that the Poles were trying to adopt the same vehicle. And while the Poles had indeed expressed interest in Christie's tanks and experimented on improving the tank design with what would be known as the 10TP, only a single prototype of that tank would be built by 1939. The other reasons lay within industrial and economic aspects and will be discussed further. Interestingly enough, though, the Soviets also obtained 1 M1932 tank for further testing. In the late 20s and early 30s, the Soviet industry was in a state of disorder and deep systemic crisis. There were many factors affecting the military industry and the rearmament. from political and administrative to a lack of technologies and experienced personnel. The leaders of the Soviet Union wanted, quote, too much too fast, following their policy of the war scare emerging in 1927. Making things harder, the first 5-year plan, and accordingly industrialization, had just begun and not produced any significant results yet. Simply put, the Soviet industry was not ready to meet the standards of the political and military leadership of the USSR within an acceptable time frame. The proposed schedule was pretty tight, even by contemporary standards. By September 20th, 1931, the UMM of the Red Army wanted 6 prototype BT tanks to be ready. By New Year's 1932, the Kharkov Locomotive Factory, or KHPZ, was to finish 25 BT tanks and 25 sets of spare parts, with another 25 tanks to be ready for acceptance trials. The first 100 BT tanks were to be ready in just 6 weeks on February 15, 1932. By the 1st of December 1932, the Red Army expected to receive 2,000 BT tanks. In total, by the end of the reorganization, the Red Army planned to have 4,497 BT tanks. This was quite an ambitious plan for a country which had started producing the indigenously developed T-18 tanks only in 1927, and, according to the previous plan of 27 and 28, wanted 1,600 MS-1 tanks, 210 maneuver tanks, and 1,640 Lilliput tankettes by 1933. As mentioned previously, there were no fast tanks in the system of tank tractor auto-armored weapons of the Red Army, which emerged in August 1929. Thus, the concept was completely new, not only to the military but also to the industry. In order to start large-scale production as quickly as possible, the Kharkov locomotive plant was chosen. This choice was not random, as Kharkov had already had enough expertise in tank and tractor production and possessed almost all the necessary equipment to build M1940 Christie-type tanks. On the other hand, Kharkov was already involved in the development and production of the T-24 medium and the A-12 Manevrenny tank. Notably, the T-24 project was costly and progressed at a snail speed, which was unacceptable for the senior leadership of the Red Army. Probably the main reason why the foreign project was chosen was its readiness for serial production. The leaders of the UMM believed that putting Christie's tank into production would be much faster, simpler, and would not allow management of the Kharkov plant to use deficiencies in the design as an excuse in case the factory would derail the production schedule. Safe to say, the management of Kharkov weren't really thrilled with these strict plans, and in fact didn't really want to produce the new combat vehicle at all. Moreover, the director of the plant, Bondaryenko, tried to stigmatize the tank by naming it wrecking. According to Gustav Bjerkes, at the time deputy chief of the UMM, quote, "It took much effort, pushing, and direct orders up to the government level to force Kharkov to build the BT tanks and to make necessary amendments to the design in the course of manufacturing." To some degree, the concerns of the factory's leadership were understandable. Kharkov was never designed for mass production of tanks on such a large scale. The factory needed to expand, thus it needed new production facilities, workshops, raw materials, machining tools, and equipment which required resources and, more importantly, time. Some machinery crucial for production was not even available in the USSR and had to be ordered abroad from Germany, Switzerland, and the USA. The BT tank project at Kharkov was entrusted to the Special Design Bureau led by military engineer of the second rank Nikolai Mikhailovich Toskin, beginning its involvement in the BT's development on May 25, 1931. On September 20, 1931, Kharkov received the order number 709-00311. According to this order, they were supposed to have had 6 prototypes built, and only 3 were actually ready. The prototypes were to participate in the military parade in Moscow in November 1931, but only 2 of them actually made it. The third tank caught fire originating from the engine compartment before even entering the Red Square. According to Zaloga, these prototypes lacked any kind of weapons and were built using mild steel plates. The production moved slowly despite all of the efforts being made. In addition to the issues mentioned before, the Tukhachevskii factory bumped into a series of problems producing armor plates for the hulls and turrets. By the end of the year, it had produced only 3 sets of hulls and turrets from the planned 50. Another source gave different numbers. The initial series of 13 hulls and 66 turrets were to be built using mild steel. Following all of the unfortunate events, on December 6, 1933, Tolskin was recalled back to Moscow and another engineer, Afanasy Firsov, took over the project. On May 23, 1931, the BT-2 was adopted into service with the Red Army, and serial production began in the same year. The production plans for 1932 were overly optimistic, with an estimated production number of 900 vehicles. This number will be reduced down to 482 as it became obvious that the previous number would just be impossible to do with existing capabilities. On October 3, 1932, the chief of the Directorate of Military and Naval Inspection, Nikolai Kuibyshev, reported to Vyacheslav Molotov, the chairman of the Council of People's Commissar of the Soviet Union, that on September 1, 1932, out of 900 tanks envisioned with the initial plan and 482 on the corrected plan, only 76 tanks were ready. Of these 76 tanks, 55 were manufactured in August. The reduced plan for September was also derailed with only 40 out of 120 completed. Kuibyshev believed it was a clear indication that the factory intentionally lowered the standards of quality control in order to commission as many tanks as possible so they could take part in these autumn maneuvers. He also stressed that the quality of the produced tanks was low. All of the BTs went to the Army units as training vehicles. According to the available reports from the military maneuvers of the Belarusian military district, on the first day of the maneuvers, half of the vehicles were out of order. After the fourth exercise, a 250 to about 300 kilometer long march, out of 28 tanks, only 7 remained. In 1932, some 35 BT-2s were given to the 5th Tank Battalion for testing, but 27 of them required extensive repairs by the end of the year. The overall attempts to increase the speed of production greatly affected the mechanical reliability of these vehicles and the quality of spare parts and components, such as tracks, engines, transmissions, gearboxes, and other things. By the end of 1933, 620 were built, with 3 being built in 1931, 393 in 1932, and the remaining 224 in 1933. Dean Nešić mentions that 610 were built, but this does not correspond with the numbers of archived documents. The BT-2 tank had a standard hull configuration, with the crew in the front and the M5 Liberty engine, oil tank, radiators, and battery mounted in the engine compartment in the back, separated by a firewall with doors. The hull had a simple box-shaped design, with the front part having a wedge shape. While the original Christie vehicle was built using welded armor, the BT-2's armor was riveted for ease of construction. The main distinctive feature of the design was the ability to move on not only tracks but also its road wheels, which in fact predetermined many technical solutions of the future BT series tanks. The BT-2 used the Christie suspension system, which consisted of 4 large road wheels on each side, 1 front idler, and a rear position drive sprocket. Each road wheel was suspended with helical springs. The springs on the steering wheels were positioned horizontally and were installed inside the combat compartment. The rest of the springs were positioned vertically inside pipes and installed between the outer armor plates of the hull and the unarmored inner wall. This suspension system allowed a road wheel vertical travel of up to 287 millimeters. While this suspension offered much better drive performance than the previous ones, it had a huge disadvantage. It required a lot of space inside the hull. For this reason, the hull interior was cramped. Another huge issue was the maintenance and replacing of damaged or worn out parts of the suspension. Maintenance was, in fact, the most exhausting and time-consuming part of the crew routine, as BT-2 tanks required all of the bearings of the road wheel arms to be lubricated every 10 hours, and all bearings had to be lubricated every 30 hours of travel. The design of the road wheels was changed during BT-2's service life. Originally, the front wheel had 12 small holes in it, while the remaining wheels had 6 spokes each. All 4 road wheels had rubber rims. The diameter of these wheels was 815 millimeters, while the width was around 200 millimeters. In later years, some vehicles were equipped with solid road wheels taken directly from the improved BT-5 vehicles. These wheels were slightly larger at 830 millimeters. The BT-2 could be driven using only the wheels by removing the tracks. In this case, the drive was provided to the rearmost road wheel, while the first set of road wheels were used for steering like an ordinary car. The driver would use a standard clutch and brake system when driving with tracks, and a steering wheel when driving with the wheels. If the tracks were mounted again, the steering wheel was stored inside the vehicle. Moving on wheels, the BT-2 could achieve much greater speeds on good roads while using much less fuel. The only problem was that it took about 30 minutes to swap out the drive system. The procedure was pretty laborious and challenging even for 3-man crews, let alone 2 men. The weight of each track was about 345 kilograms. The crew had to remove the tracks, disassemble them into 4 parts, and fasten them to the track shelves with belts. The problem was so acute that on May 1932, the UMM of the Red Army ordered to, quote, mechanize the removal and putting back of the tracks, as the time of 30 to 45 minutes required for removal and 15 to 30 minutes for putting back the track is extremely long, unquote. After changing from tracks to wheels, the crew had to adjust all the springs to align the vehicle and get the road clearance even at 350 millimeters. The wheel configuration could only effectively be used on good roads, which were pretty rare in the USSR during this period. Driving with them off-road was generally a bad idea. However, the wheeled setup was in no way meant to be used anywhere near the front lines. When approaching the enemy, the tanks could be changed to track configuration before proceeding. Once removed, the tracks were usually placed atop the track guards. The tracks used were of the Christie type, which were 255 mm wide with 46 lengths, 23 flat and 23 with grousers. As this track was produced in the Soviet Union, its quality was poor and frequently prone to malfunctioning. The BT-2 tanks were powered by a 400 horsepower Liberty L-12 engine, reverse engineered and produced by the Soviets under the name M5. In its essence, it was a 12-cylinder, V-shaped, liquid-cooled, carbureted aviation engine. With a full weight of 11 tons, the BT-2 had a power-to-weight ratio of 33.2 horsepower per ton. Normally, the engine worked at about 1,650 RPM. The engine could be started with 2 1.3 horsepower Mach starters, 1 2 horsepower Scintilla electric starter, or if you're desperate, a hand crank. According to official specifications, the serial BT-2 could reach a maximum speed of 70 to 72 kilometers per hour on a dry paved road. Some sources even mention an astonishing 110 kilometers per hour, but that sounds like an exaggeration. The maximum and average speeds in different road conditions are given in the table below. If the BT-2 was on tracks, the speed was reduced to a still respectable 50 to 52 kilometers per hour. Depending on the drive type, the operational range with its full 360 liters of fuel ranged from 120 to 200 kilometers. Older sources, such as J.F. Milsom, gives a range of 300 kilometers, but this is doubtful. The gearbox had 4 forward gears and 1 reverse. On top of the engine compartment, a hatch door with a large air filter was placed. Originally, the BT-2 tanks were not provided with a protective mesh fence for the air intakes, but in later years, some vehicles were equipped with it. In addition, the large external mufflers would also be replaced with simpler twin exhaust pipes. Capricious carburetor engines were prone to overheating, malfunctions, and even fires. While the Liberty L-12 and its M5 copy were somewhat problematic, the main reasons for accidents were inexperienced crews and technical services, poor manufacturing quality, and even fire safety violations. Some Russian sources mention numerous accidents caused by the crews smoking near the fire-prone engines or while refueling. On the other hand, the head of the UMM of the Red Army, Tukhachevskii, in his report to Voroshilov on April 29, 1934, mentioned, quote, all BT tanks have Liberty-type aircraft engines purchased in America and partially M5 engines transferred from aviation to industry for installation on BT tanks. Practical experience has established that these engines can operate in tanks 400 to 450 hours before overhaul, unquote. This number is quite remarkable on its own, but some BT-2 tanks survived up until 1944 in the harsh conditions of the Northwestern Front. This indicates the engine itself was reliable enough when handled carefully, even taking into account that the Northwestern Front was quite static until 1944 and BT tanks were constrained to guard duties. The BT-2 was lightly armored. Initially, the Red Army wanted the BT tank to have not less than 20 mm on the front, 13 mm on the sides, and 6 mm on the roof and on the bottom. Early production models were made of Mark D armor plates and had armor thickness ranging from 6 mm to 13 max. The hull's front was 13 mm thick, the sides were 10 to 13, and the rear was also 13. The top and bottom of the hull were protected with 6 mm, while the turret had 13 mm all around, with its roof having 10 mm of armor. BT-2 tanks of the later production batches had 13 mm on the front, side, and rear. The roof armor thickness was slightly increased from 6 to 10 millimeters, and the turret was still protected by 13 millimeters all around. After the Istorski plant started manufacturing a new type of armor named PI in September 1932, the maximum thickness of the hull and turret increased to 15 millimeters. The small frontal driver plate was positioned mostly at a 90-degree angle, with the rest of the front having a pyramidal shape placed at a 31-degree angle. Notably, the BT-2s had no vision slits protected with triplex glass, nor pistol ports protected with armored shutters. The two Christie tanks purchased in America had no turrets at all, and since the Soviet leadership wanted a tank with a gun, it was necessary to design a new turret from scratch. According to Zaloga, the Soviets appointed engineer Anatoly Kolesnikov to design a turret. Kolesnikov indeed worked at the Kharkov Design Bureau under the leadership of Afanasy Firsov. However, Kolesnikov finished his education at the Leningrad Tank Academy and joined the design bureau at Kharkov in 1931. Given the tight schedule, it seems doubtful that the leadership could have entrusted the design of the turret to the young designer and without any supervision. It was most likely a team effort, and Kolesnikov was part of the design group. Due to the importance of faster project implementation, the Soviet engineers chose to design a simple cylindrical turret. The armor plates were held in place with rivets. The top of this turret consisted of a flat rear part, where a square-shaped hatch door was placed. Additionally, there was a small hatch for flag signaling to the left of the hatch door. The frontal half of the turret top was angled downward. The early turret designs did not have the two additional square-shaped protective covers over the gun mantlet, which were added later for better protection. During production, the turret was also provided with small vision slits. Some turrets even had pistol ports closed with armored plugs. Initially, BT-2s were to be armed with the PS-2 37mm gun developed by Pyotr Syachentov and a coaxial machine gun. The gun was actually a Soviet attempt to improve the performance of the French Hotchkiss 37mm. The plan was discarded once the Soviets decided to adopt a copy of the German Rheinmetall 37mm anti-tank gun instead, as it was a more modern design. Based on the German gun, the Soviets developed a tank version named the 37mm B-3 tank gun, factory designation 5K, K standing for Kalinin plant, where the gun was developed. In the summer of 1931, it was decided to adopt a mount with the 37mm B-3 tank gun and a coaxial 7.62mm machine gun as the standard armament for BT-2s. There are different interpretations of this decision. According to Russian sources, the main artillery directorate of the Red Army failed to design the prototype of the mount and therefore cancelled its serial production. As a result, in the first quarter of 1932, the Istorski plant had to alter the blueprints of the turret to accommodate two separate mounts, one for the 37mm and the second for the machine gun, and then change the whole first batch of 60 already produced turrets. After that, the Mariupol factory and the Istorski plant produced the second batch of tank turrets, now redesigned for separate mounts. Each factory produced 120 turrets for 240 total. It was planned to switch to a new mount with a 45mm 20K gun and a coaxial DT machine gun, starting with the 301st tank. However, extensive testing revealed that the small size of the serial production turret simply did not allow that to happen. Instead, the Soviet engineers designed a new, bigger, unified turret, which was subsequently used on the T-26 and BT-5 tanks and on some armored cars like the BA-3 and BA-6. According to Zaloga, the initial batch of 60 turrets were designed for Syachentov's cancelled PS-2 gun. As the B-3 gun was bigger, it was quickly realized that the turret's design did not allow it to accommodate both the new gun and the coaxial machine gun. The Red Army's command did not agree with the idea to omit the machine gun completely, thus the Istorski factory had to find another solution. Eventually, the first 60 turrets were altered to accommodate two separate mounts, the B-3 in the mount and a DT machine gun and a ball mount to the right of the gun. To add more confusion, there are also different opinions on the adoption of twin machine gun mounts as a main armament for BT-2s. According to the version given by Russian authors M. Pavlov, I. Pavlov, and I. Zeltov, Factory No. 8 was able to deliver only 190 B-3s to the Kharkov factory. As there were not enough tank guns, in May 1932, the Soviet leadership decided to arm the remaining BT-2s with two 7.62mm DT machine guns in twin mounts named DA-2. The DA-2 was tested and adopted into service in the fourth quarter of 1933. Curiously enough, the DA-2 mounts were installed by the Army Repair Services. In turn, Zaloga sticks to the version that the Kalinin Factory No. 8, which was the main production center of the gun, received orders to stop production of the B-3 guns in 1931 due to the decision to switch production to a new 45mm gun. At the time, only 352 B-3 guns were actually built. Eventually, the solution to modify the BT-2 turret to be able to house the new 45mm gun failed. Despite much testing and modification of the turret by adding a rear bustle, it was just not possible, mostly due to the turret's small size. Another suggestion was to reuse any available PS-1 guns, which were initially used to arm the obsolete T-18s. This proposal was also rejected due to the PS-1's poor armor-piercing performance. As there were only enough B-3s to equip slightly more than half of the BT-2s, the remaining vehicles had to be left without any main armament, at least until another solution could be found. Despite lacking its weapons, some of these BT-2s were still used on military parades. As a result of the given circumstances, BT-2 tanks had 4 different sets of armaments. First, just a 37mm gun. Second, a 37mm and a 7.62mm machine gun in a ball mount. Third, 2 7.62mm machine guns in a twin mount, and finally 3 7.62mm machine guns, 2 in the twin mounts and 1 in a ball mount. The twin machine gun only variant appeared for 2 reasons. Firstly, at some point it became apparent that the commander was not able to operate 2 machine gun mounts efficiently at once, and secondly, the third machine gun just took up too much space in the already cramped turret. Therefore, a certain part, the precise number is not known, of the BT-2 tanks armed with twin machine gun mounts had the ball mount removed, with an armored shutter being placed instead. However, a document dated for the 29th of June 1939 indicated 2 variants of the standard armament for BT-2s, a 37mm gun and a DT machine gun, or just 3 machine guns. The standard armor-piercing round for the B-3 37mm had a weight of 0.66 kilograms and a muzzle velocity of 820 meters per second. It could, at a range of some 500 meters, penetrate 28 millimeters of armor at a 30-degree angle. The BT-2 was also provided with 0.645 kilogram high-explosive rounds. The ammunition load for the 37mm was 92 rounds stored in ammunition bins located in the hull. The elevation of the gun ranged from 5 degrees down to 21 degrees up. The secondary armament consisted of a 7.62 machine gun with 2,709 rounds of ammunition. BT-2s armed with twin machine guns had 5,166 rounds of ammunition. The machine gun ammo was stored in drums, with 63 rounds in a drum. BT-2 gun-armed tanks had 43 drums on board, and machine gun BT-2s had 82 drums.
That's all for this video. Make sure to follow our website, we'll be releasing new articles on the regular. You can follow us on Facebook, Twitter, Instagram, or Reddit, and if you use Discord, there's a link to our community server in the description. Also, likes, comments, and subscriptions on YouTube are greatly appreciated. If you would like to help us continue to develop and expand, also consider donating on Patreon or PayPal. All of the funds will be used to help us enhance and design new articles and features for you. Until next time, keep us in your sights.